Hey guys, how we doing? Happy Monday. We are slowly and steadily getting to the end of trimester 3, but we are very, very quickly approaching the end of our quadratics unit. So let's take a moment to talk about our quadratic final assessment. We're going to start it on Thursday, May 21st, and we're going to finish it the following Wednesday, May 27th. Part 1, you're going to get to choose an equation and identify key features of that equation. Part 2, you're going to solve for the roots and interpret in context. We're going to talk a little bit about this today. And part 3 is going to be a wrap up. And you're going to be assessed on 3 learning goals. Functions B is your characteristics. Quadratics is how you're solving for the roots, whether you're doing factoring or quadratic formula. And then revision and reflection. We haven't spoken about this learning goal in a while, and you'll see how we incorporate it into your final assessment. So let's get into today's work. All right, so our rocket situation, here it is again. And we're talking about the exact same equation, h of t equals negative 4.9 t squared plus 50t plus 2. And what do we know? Just by looking at this equation, what do we already know? Take a moment, jot it down. One thing we know is about the a value, and that tells us about the concavity. In this case, because a is negative, we have concave down. We also know the y-intercept, which is going to be our c value, which is going to be 2. But I can't look at this equation and find the roots. I'm choosing to use the quadratic formula because a is a decimal, b is a really big number. So if I try to do product sum table, I feel like I'm going to be here for a while. So quadratic formula. Here's all the work shown out all the way down to the last step where the roots are split up between our plus equation and our minus equation. So what I'm going to do is I'm going to pause here for a second. We're going to go over to Desmos together and type these in to evaluate for the roots. Okay, so we had, first off, a fraction, negative 50, which was our b value. Let's do plus first. Square root of 2539.2 divided by negative 9.8. Wow, that's a really long number. Okay, so I'm only going to take these first 3 numbers. I have 0.039 negative, and I'm going to take the same equation, copy it, paste it, but instead of plus, I want the negative equation. Alrighty, and we get 10.243. All right, let's write that down. 10.243. And this is our final step. Let's go back and let's type them in. Here are the roots. Oh, shoot, but I wrote a t here, but I was evaluating for x, so which one's right, though? In our original equation, our variable was t, not x. So now when I'm writing the roots, I have to write t equals. So I have negative 0.0039. I also have 39, sorry. And then we have equals 10.243. Okay. If you guys are still having a problem with the Desmos calculator, myself and Ms. Kwong are more than happy to help you. So here are the roots. But I'm not so sure if we're done yet. Let's keep going. Let's present this again. All the way. All right, here we are. The question is, when is the rocket on the ground? But we actually have to talk about where is the ground. In this situation, since we're talking about a rocket going up and coming down, The x-axis in this case, let me see if I can get a line here on this x-axis for you guys. You want a line right here. This line, make it nice and bright for you, is the x-axis. So instead of asking when is the rocket on the ground, we're really asking when does the graph hit the x-axis. Okay? And this happens, so when does the graph hit the x-axis? So what are we actually looking for? We are entailed looking for the roots that make sense in this situation. All right. So again, we have the negative root and we have a positive root. And let's keep going. All right, my apologies, guys. All right, let's keep it moving. So we're looking for the roots that make sense. So let's keep it moving. All right, so we know the rocket will be on the ground. It's touching the x-axis at the two roots that we saw for, which was t equals negative 0.04 from the graph, and t equals 10.244, right? So this really means that the rocket is on the ground at negative 0.4 seconds and t equals 10.24 seconds. But I never explained how we got seconds, so let's go back for a second. If we're talking about something being on the ground and we're talking about the height, so the original problem told us that we're talking about the height, how high it gets, and then we have this t value. T in this case actually is telling us time. So we're talking about how high something's going and how long it's taking to get to that height. So here our x-axis, is time. And in this case, time is going to be seconds. Okay? And we also know, like we just said, that the height, the y-axis, is going to be height. And it could be since we're talking about the toy rocket, let's talk about feet. So I got height, the y-axis, from the situation. They told me that. And then I'm talking about h of t. And in this case, t is going to tell me time. Okay? So go back to what we were talking about. So now our roots now are actually seconds. But does this actually make sense though? I have a negative seconds and I have a positive seconds. Time cannot be negative. So in reality, I need to reject this negative root. Negative 0.04 seconds does not make sense. So in conclusion, the rocket will be on the ground at 10.24 seconds because that's when the graph hits the x-axis in real time. And we talked about the x-axis being the ground. All right, guys, I know that was really quick, really choppy. Drop into office hours later or drop into live later if you need some assistance at 1:20. If not, you always could shoot myself, Miss Kwong, Miss Mish, an email or a G-chat. We are more than willing to help you guys. Have a great Monday.